Hello, good afternoon, and welcome to the August Intermountain West DEW's Drought and Climate Outlook webinar. This webinar series, hosted by NOAA's National Integrated Drought Information System, or called NIHHIS, is held every other month with the intent to provide the region with timely information on current and developing drought conditions, in addition to providing a forum to hear from experts on the impacts of these conditions in the region and additional resources that might be useful. I'm Meredith Muth, the acting coordinator for the Intermountain West Regional Drought Early Warning System, and I will be monitoring the webinar today. For those of you unfamiliar with NIHHIS, this federal interagency program, hosted by NOAA, was created by Congress nearly 20 years ago with a mandate to help the nation prepare for, mitigate, and respond to the effects of drought. So NIHHIS does this through a series of activities, including the coordination of these regional drought early warning systems, shown on the map here, and in delivering information on drought conditions and impacts through the regional DEWs networks, as well as through the U.S. drought portal known as Drought.gov. This webinar will focus on the Intermountain West DEWs region, shown here in the dark blue. Please see the links in the chat box to sign up for the Intermountain West Regional DEWs listserv to keep up with the latest regional drought updates, webinars, and news. Next. Today's webinar will provide an update on drought in the region and current outlooks. In addition, we have several speakers that will be sharing with us resources and tools related to extreme heat in the region. Our first speaker today will be Russ Schumacher. Along with his faculty position in the Department of Atmospheric Science at Colorado State University, Russ serves as the Colorado State climatologist and is the director of the Colorado Climate Center, a role he has held since 2017. His research and teaching interests include extreme precipitation, weather systems, the climatology of precipitation, and Colorado's weather and climate. Our second speaker will be Morgan Zabow. Morgan is the Community Heat and Health Program Manager with NOAA's Climate Program Office. In this role, she co-leads an interagency heat communications team, manages Heat.gov that you'll hear about today, and leads NOAA's urban heat island mapping campaigns, where she works with community members and organizations across the country and internationally to map the hottest parts of their communities. Our third speaker will be Jessica Lee. Jess is the National Weather Service Public Weather Services Program Coordinator, overseeing national procedures and guidelines involving extreme temperatures, both heat and cold, wind, frost and freeze, fog, dust, and other weather phenomena. Our final speakers will be Andrea Brush-White and Eloise Armour. Andrea has been with the city of Grand Junction in Colorado for 3 years as the sustainability specialist, and she is working on implementing the city's recently adopted sustainability and adaptation plan. Eloise is pursuing her master's in environmental management and ecology while serving as the Resilience Fellow for the city of Grand Junction. I'm excited to hear from this excellent group of speakers representing federal, state, and local expertise. Thank you again to all of our speakers for joining us today. Now, questions for the speakers will be taken at the end. Please enter your questions at any time using the question box in the GoToWebinar toolbar and identify when possible if your question is for a specific speaker. A recording of this webinar will be posted on Drought.gov. Now let's get started with our first speaker. Russ, I will turn it over to you.
Okay, great. All right, good. Looks, let me put it in presentation mode again. Look okay?
Looks great.
Okay, all right. Thanks for being here, everybody. Glad to be with you. I'll be giving the drought and update and climate outlook today. I'm going to blast through quite a bit of information here, but happy to take questions at the end to revisit anything if I went through it too quickly. So we'll start with the big picture here. The U.S. Drought Monitor, as of last week, over the Intermountain West DEWs region, that you can see here. Most of the region is currently in drought. So a little over 73% of the Intermountain West Dew's region is in D1 or worse drought, and over 18% of the region in D3 or D4, the two worst categories there. Um, if we go back just to kind of see how we got here, go back to the start of the water year, October 1st, much of the region was not in drought at that point. It's about 36% of the region in drought as of October 1st, and now that's basically doubled since the beginning of the water year. And if we look at the changes over that time period, that's what this map shows here. So if where you see the yellow and orange and brown colors, that's where drought conditions have worsened since the start of the water year. If you see the greens and blues, that's where they've gotten better. So you see most of the region west of the Continental Divide has seen drought expand and get worse since the beginning of the water year. And then in contrast, east of the Continental Divide, eastern Wyoming, eastern Colorado, eastern New Mexico have generally been wetter than average, or at least to where the drought conditions are not as bad as they were several months ago. So let's dive into the factors driving this drought a little bit closer. This is precipitation, and now this is for the water year, so the 10 months of the water year so far, going through the end of July. And this is a historical ranking over the region. So where you see the browns, it's among the driest first 10 months of the water year on record. If you see the greens, it's where it's been among the wettest water years. So the places that jump out on the map here are especially Arizona. So most of Arizona, especially southern Arizona, in top 10 dry, or even some spots that are record dry in this data set over this period. Much of Utah, western Colorado, all quite dry. Parts of eastern Colorado, eastern New Mexico, in contrast, have been very wet, among the top 10 or 20 wettest starts to the water year over those areas. This is the same map, but now just for the last 2 months, for June and July. And we see that, for example, northern Utah, northwest Colorado, southwest Wyoming, extremely dry over this period, with some pockets of record dry for the months of June and July. Not quite as extremely dry farther south into Arizona, New Mexico. And then again, you see the areas east of the Continental Divide relatively wet over that period. These are now similar maps, but for temperature. So again, the ranking for the first 10 months of the water year, basically everywhere in the region has been very warm. Most of the region, top 10 warm start to the water year. That's everywhere you see in this darker red color as having top 10 among the top 10 warmest first 10 months of the water year. Only exceptions are like southeast Colorado, northeast Wyoming, parts of eastern New Mexico. And this is, again, just for the last 2 months, June and July. Again, everywhere west of the divide pretty much has been warmer than average. East of the Continental Divide, not quite as extremely hot. But yeah, you see, again, many of those places that were both record dry or near record dry over this 2-month period are also near record warm. Okay, so now we'll take a look at some of the impacts here. This is stream flows. So this is from the USGS water dashboard. So anywhere you see the like brown colors here, that's below average stream flow. And actually in their color scale, this red color is all-time lows. So there's a few pockets. I'll point out one here just in northwest Colorado on the White River, circled there. This is the plot showing the stream flow at on the White River near Meeker. All the historical years are in these gray lines, and you can see the record highs and the record lows. This year is in the black, and you can see that for early August, it's at record low stream flow on the White River at Meeker, and very close to the all-time record low flow that's been recorded at any time of year. So very poor stream flow conditions in that part of Colorado, and really throughout the Colorado River Basin. The stream flows are below average in most places. And that then is connected also to the big reservoirs in the Colorado River basins, Lake Powell and Lake Mead. This year is shown in black, or the current conditions are in black. with respect to the history at that station. Both are not as low as they were a couple years ago, but again, creeping down towards the all-time record lows in terms of storage. You can see that typically you would get a bump in the spring or in the early summer from snowmelt, especially in Lake Powell. That didn't really happen this year. And then the other big drought impact lately has been wildfires. This animation is so this is the Dragon Bravo fire here in northern Arizona. I just checked, it's now over 126,000 acres. The seventh largest in Arizona history, as far as the information I got as of yesterday. It's possible it's moving up the list even further. Fire in Utah here. There are now some big fires that have just grown in the last couple days in western Colorado as well. This is a photo from one of our field technicians, Christy Davis, of the Lee fire west of Meeker in northwest Colorado as of last night. Okay, so now we'll jump to the outlook and kind of run through that pretty quickly. So one thing to keep in mind here is that August is on average the wettest month of the year for much of the Intermountain West region. So anywhere you see this dark green color, like almost black color, it's where a lot of the annual precipitation comes in the month of August. So you can see that's most of New Mexico, much of Arizona, southern Colorado. So August is when we expect to be getting a lot of rain in the North American monsoon in the Southwest. But at least up to this point, that is not what we're seeing in August so far. So extreme heat in the Southwest right now. I'm not going to focus too much on that because we're going to be hearing a lot about heat as we go for the rest of the webinar. This is a 7-day precipitation forecast from NOAA for the next 7 days. That's very dry, especially for early August when these places this part of the country tends to be getting regular monsoon thunderstorms. This is what it looks like as a comparison to average over the next 7 days. So in some places, the average at this time of year is like an inch of rain per week. So a week with zero, the drought starts to get worse pretty quickly. If we look out further now, this is the 8 to 14 day outlook. So this is for like the middle part of August. Continued hot across the region, but with going back towards near normal conditions for precipitation and some above average tilt towards above average precipitation in that part of the month, at least in the southern part of the Intermountain West. So maybe some monsoon rains returning, not this week, but maybe later next week. But if we add that up over the whole 15-day period, just look at the map on the left here, which is the percent of weather forecasts ensemble members that show below average precipitation over the next 15 days. And it's actually a large swath of the country, but especially, pretty much all of the Intermountain West region. The models are unanimous that the next 15 days are going to be drier than average during a time of year when it is typically relatively wet. Okay, so looking out further, this is for the month of August as a whole. It shows, similar to what we're seeing in the, now we're getting into the kind of the weather be a little bit beyond the weather forecast time frame, but the general picture for August is hot over the Intermountain West, very high confidence in warmer than average August, and generally dry across the region. So the drought conditions are, there's not, in the near term, there's not a lot of positive signs in terms of the drought situation improving. It will likely get worse at least over the next few weeks, kind of through the rest of August. We look out farther now for the fall, not quite the fall season, but August, September, October. This is the CPC outlook. And so again, with these, think of this as like a measure of confidence, not so much a measure of magnitude. So this is a pretty high confidence forecast. Like if you look at the pie chart here for Durango and Southwest Colorado, instead of, what would be a random chance would be 33% chance of above, below, or near normal. Here it's up to 56% of above normal and very little chance of being cooler than normal for the August, September, October time period. But precipitation is less certain over that time frame. It's a slight tilt towards drier than average conditions, like up in the northern plains and into like eastern Wyoming, northern Colorado. Not as much signal further south in the Intermountain West there. And then looking out to the signals for next winter, one tool that we have that gives us some predictability is ENSO, El Nino Southern Oscillation. Um, what this graph shows is the probability of being either in El Nino in red, neutral conditions in gray, or La Nina in blue. You can see that basically through this, we're currently in neutral conditions. That's expected to persist through the summer. As we get into next fall and winter, it looks like it will either be continued neutral or we could go back into La Nina. So those are the options we're looking at. Generally, La Nina is dry for the southwestern U.S. In the winter and through the spring. So staying neutral would be better news, but we'll have to wait and see how this plays out as we get into the further out there. So some takeaways: Intermountain West is in the midst of widespread and worsening drought west of the Continental Divide. This is causing impacts to agriculture, water supply, enabling large wildfire growth across the region. It's not going to get better, certainly in the next 7 to 10 days. It'll be getting worse over that time period, and it looks like August as a whole will be hotter than drier than average across most, if not all, of the region. Longer term outlooks are uncertain, as they usually are, but at least through fall, the tilt is towards warmer and drier than average conditions, and then we'll have to see about whether La Nina may return for the winter. So that is what I have, and there's information how you want to, if you want to get in contact with me and some of our things that we send out from the Colorado perspective for our monthly updates and our blog. So I will leave it there, and we'll do questions at the end.
That's great. Thanks, Russ. And I'll do another shout out for the excellent communications and products and tools from the Colorado Climate Center. If you're not familiar with it and you're in Colorado, I encourage you to check that out. I'll put the links in the chat shortly. Russ, you also did an excellent job of setting us up for the next 3 presentations, which are focusing on extreme heat. As you mentioned, most of the region, especially in the west, has been hotter than normal, and hot conditions are expected to continue at least in the near future. And so with that, I'm going to pass it over to our first of 2 presentations that will be focusing on resources and tools related to heat, and then we'll follow that up with some examples at the community level. So Morgan, I will pass it over to you to talk about Heat.gov.
Thanks so much, Meredith. Hi, everyone. It's a pleasure to be speaking with you this afternoon. My name is Morgan Zabow. I'm the Community Heat and Health Program Manager in NOAA's Climate Program Office, working on the National Integrated Heat Health Information System, or NIHHIS. So very timely that we're talking about heat right now, as part of the Desert Southwest is under a heat advisories. And so first, I want to start off this presentation with just a snapshot of a few of the media articles we've seen this summer of the heat that's happening in the Intermountain West. So we're seeing it across the entire region. Again, to just reinforce what we're experiencing this summer. So what you're seeing here on this map is historical rankings of average max temperatures across the country. And you're seeing a lot of white squares, and so the white squares are kind of your middle of the average temperatures, and then the pink blue that we're especially kind of seeing as we're going towards the east is indicating lower as compared to average. Now, when you look at the Intermountain West, we are seeing orange, red, and especially dark red colors, and that's indicating some of the highest or in the highest percentile temperatures as compared to some of the historical averages. And there's a couple places, including in New Mexico, that have seen record-breaking top-tier temperatures this summer. And to also put into home what this means in perspective for our health. So what you're looking at here is CDC and NOAA contributed to a heat and health tracker. And so this heat and health tracker, which is looking at the health and human services regions, which is why it looks a little bit different than what Russ just showed. It's the rate of emergency department visits associated with heat-related illness. And there was a pause in this particular tool working because of some of the the things that happened over at CDC, but the tool is back online. So why you'll see some of the missing data if you go to this tool. But for July 27th, in part of this region, including Utah, Colorado, part of Wyoming, we did see some extremely high rates of heat-related illness, exceeding the 95th percentile, based on historical data as well. So this is really reinforcing that this heat is causing emergency department visits, and we know that these numbers are an undercount, because in many cases, if a patient comes into an emergency department as a result of heat-related illness, it can exacerbate other underlying conditions such as cardiovascular issues, kidney issues, and those might be the ones coded instead of as a heat-related illness. So even though these numbers are still high, it's probably much higher than what we're even seeing here. And so, again, to put in perspective for this week, as I mentioned, there are parts of Arizona and New Mexico that are under a heat advisory or an extreme heat warning. And this was a graphic that was put out by the National Weather Service just this morning. And so there is dangerous heat in these regions for Tuesday and Wednesday, and especially with high temperatures expected to be in the mid 110s, and that there might be some record-breaking heat occurring. So especially if you're living in this part of the country, it's really important to be taking care of yourself, watching for heat-related illnesses, following heat safety tips that we'll talk about on Heat.gov in a second. And so looking ahead, Russ just showed some of the CPC graphics as well that we're mentioning heat, but we're looking here at a 6 to 10 day temperature outlook. Again, seeing that much of this region is very likely to be above average temperatures for the next 6 to 10 days. And on the right side, you can see the HeatRisk tool that Jess will talk about just after me. But once again, indicating that part of this region is under major or extreme heat risk this week. And so, if you are looking for more information about heat and how to protect yourselves and your loved ones and maybe get more heat data, whatever it may be, Heat.gov is the premier source of heat information for the nation and is also the website for the National Integrated Heat Health Information System, or NIHHIS. And NIHHIS is so many federal agencies all working together to be addressing heat, and not just heat and health, but also looking at heat in agriculture, heat in the economy, heat in infrastructure, and so much more. So we launched Heat.gov in July 2022, and if you've never visited the website, highly recommend you check it out. But I'm going to show some screenshots of the website for you all to just show some of the different web pages that we have that maybe have helped you all. So this is on our front page. Right when you go to the front page, you've got some information on news, some ready, easily clickable links, but we've also got some widgets like on the right-hand side. We're able to pull data to see exactly how many people in the US are under heat alerts, and that's heat advisories, extreme heat warnings, and watches. And so as of today, over 16 million people in the US are under heat alerts. And additionally, it's pulling in weather station data where you're able to get that information about how you're being impacted by heat. We also have the seasonal temperature outlooks, again, what we just saw with that Russ just showed this exact one, looking at August, September, October. But we've also been working with the National Weather Service to be developing these key messages for extreme heat. So at the top of Heat.gov, we have a red banner that indicates when those key messages are out. And so one of the key messages that we did develop was for the Southwest extreme heat right now. And the key message is heat to be at dangerous levels across the desert Southwest this week. And so not only does this key message show the map and show some of the records indicating what is happening, but it also provides messages for decision makers, emergency managers, public health officials, whoever it may be, and having those messages that they can easily grab and disseminate to the public. Also on the front page of Heat.gov, we've got some maps of, again, current conditions and some future outlooks. So you're able to see things like the monthly temperature outlook, and this is for August, showing, again, that there's about a 50% chance of being above normal temperatures for this month in this region. And we've also got some information on future outlooks as well. So we've got some maps that's showing temperature projections for 2050, showing what the number of days per year warmer than the top 1% historically could be. And so we selected Denver, Colorado for this one. And historically, from 1976 to 2005, there was about 4 extreme heat days experienced, and based on temperature projections, could be 32 days by the year 2050. So additional things that we have on Heat.gov, we have a whole page of heat tools and resources, and these are tools and resources across the federal government that we've put all together in a one-stop shop for you to be able to find. So in addition to things like the CDC Heat and Health Tracker, the HeatRisk tool, we've also got resources like the LIHEAP, which is the Low Income Home Energy Assistance Program cooling toolkits. So these toolkits are not just for residents, but also for local governments, decision makers who are looking for information about help with cooling bills. And so this includes things like short videos, social media toolkits, outreach flyers that again can be disseminated to the public. We've also got things like the EMS heat tracker, which was down for a few months, but is back online. We're so happy about that, which is mapping emergency medical services and the responses to heat-related illnesses specifically. So again, we know this data is probably an undercount, but this type of data is really important for, again, your decision makers, healthcare professionals, public health departments, emergency managers who are really looking to understand how extreme heat is impacting their communities. We've also got some information about who is most at risk to extreme heat, because while everyone is at risk to extreme heat, we know that certain populations are more at risk due to certain factors. So this includes children under 5, especially because children aren't able to thermoregulate their body as well, may not be able to communicate to parents, caregivers about how they're feeling. Also includes older adults, people experiencing homelessness, people with disabilities, people with chronic health conditions, and so much more. So we put this page together to explain how certain populations and why they're at higher risk, and also includes some links to additional resources, including some really great like CDC health checklists that you could talk to your doctor about how your child is more at risk to extreme heat and information like that. We also have a plethora of information for planning and preparing for extreme heat. So when you click on the planning and preparing page, on the left-hand side, you'll have all of the resources and guides broken down by stakeholder group. So if you're right here on the slide, if you're looking for information in Spanish, we've got that at the top. And then as you continue to go down, we'll have information for decision makers, for employers, employees, for tribal communities, for public health departments, for healthcare providers, and so much more. And then on the right-hand side, we provide some tips and information about staying safe before, during, and after extreme heat. And one of the biggest things that we've done as well is we have a communications group that developed this orange and red man graphic depicting the signs of heat exhaustion and heat stroke. So again, really making sure that we're getting that messaging out about extreme heat and safety tips for people to be able to be safe, because extreme heat, we refer to it as a silent killer. It's not the same as a tornado or hurricane that you can see the impacts happening or after it happens, but it might be something that is much more slow moving. So we want to make sure that we're getting this information out to the public. As you continue to go down the page, again, much more safety tips about heat-related illnesses. Additional resources that we have on Heat.gov are supporting local heat action planning. So one thing that we've been able to develop and work with different communities on is heat tabletop exercises. And in this particular region, we did one in Phoenix, Arizona in early 2023. And so this is working with different stakeholders in the cities to be able to kind of simulate extreme heat events and work on long-term as well as short-term planning and heat resilience. And it's getting everyone together in a room for, can be 1 or 2 days, and putting together a scenario of if this extreme heat event happened, how would we localize resources? How would we make sure that everyone is on the same page and responding to the event properly? So we've got this great guide to be able to help communities be able to do that. And then the other thing that we've been developing as well is a maturity model for heat governance. So this is really for local communities to understand where they are in developing heat action plans, or to be able to improve heat governance and making sure that we are protecting communities from extreme heat. The last thing that I want to mention on Heat.gov is our urban heat island mapping campaign. So many people are familiar with our program through this. We've been doing urban heat island mapping since 2017, and since then have mapped more than 80 communities across the country, as well as a few international locations as well. And this is a community science project that typically happens over the course of one day, that community members come together and collect this heat data, and are able to understand how heat differs between neighborhoods. And we've done a couple of these mappings in the Intermountain West, including Grand Junction, Colorado, which will give their presentation in a bit, as well as Boulder, Colorado. We've had Santa Fe and Albuquerque, New Mexico, Sedona, Arizona, as well as Salt Lake City. So we're really excited that we've been able to do this work, and all of these maps and the data is available when you go to the Urban Heat Island section of the website, and all widely available. And so that is it. Again, really encourage you to go to heat.gov. The last thing I want to leave you with is we're doing a August heat awareness social media campaign to get the word out, again, about the heat that is happening. And so we're using hashtag cooldown Tuesday. So every single Tuesday in the month of August, we are posting about extreme heat. And again, making sure that we're getting those messages out to our communities. So thank you so much.
Thank you, Morgan, and for reminding us about extreme heat as a silent killer and sharing so many valuable resources. We really appreciate it. We're now going to transition to a specific tool out of the National Weather Service, and I will let Jess tell all about it. Turning it over to you. We can see your slides.
All right, thank you, Meredith. Russ and Morgan have already shown a couple examples of heat risk in their slides, but I will go a little more in depth into what heat risk is. And just a note that heat risk has been available in Western states for almost 10 years, so some of you may be pretty familiar with it, but it was just last April of 2024, that heat risk was expanded across the rest of the contiguous United States. Next slide. HeatRisk is a collaboration between the National Weather Service and the Centers for Disease Control and Prevention, CDC. It uses National Weather Service temperature forecast and climate data, along with CDC heat and health thresholds, to identify days that may pose an elevated risk for heat-related impacts to occur. Heat risk is divided into 5 simple color number categories for each 24-hour period in the 7-day forecast, and it provides users with a spectrum of potential impacts. Think of analogies such as the air quality index or UV index, which express complicated information in an easy-to-understand color number approach. Heat risk helps individuals understand and personalize what forecasted heat means to them and what actions they may need to take. It also gives users the flexibility to act when they need to, and is especially useful for individuals who are sensitive to heat and for those who may need to make decisions below our traditional heat advisory and extreme heat warning criteria. Next slide. Looking at the basic tenets of heat risk, research has shown that communities adapt and build to their local climatology, and that it is possible for people to acclimate on a time scale of a week or two to a point. Research has also shown that some level of heat can be physically dangerous to the human body, no matter the time of year. But it also suggests that everyone has different heat tolerances, meaning that a single threshold does not work for everyone. Next slide. HeatRisk uses the 95th percentile of temperatures to identify heat episodes that are extreme for a particular location. This is a method used in many studies and heat health warning systems around the world. Temperature is the first order driver for impacts, and other items like wind, humidity, and clouds are secondary drivers. They are important, but at the base level, temperatures drive heat impacts. Humidity and air mass characteristics can be approximated with minimum temperatures and diurnal temperature ranges. And in order to be consistent, the same framework rules need to be applied in a similar fashion across the country. Next slide. Heat risk accounts for several key factors. The big differences between heat risk and other traditional approaches are that both the high and low temperatures play a role in predicting the 24-hour value of heat risk. The thresholds identifying the heat risk categories change throughout the year based on local climatology, allowing heat risk to better account for acclimation. The daily forecasted difference between maximum and minimum temperatures is used to estimate humidity levels. The entire 7-day forecast period is examined to identify periods where excessive temperatures are prolonged, and CDC heat health thresholds are used to inform what temperatures are dangerous to humans. Next slide. As mentioned earlier, heat risk is divided into 5 color number categories. The highest or worst category is extreme, colored magenta and numbered level 4. This category accounts for rare, long duration, and extreme heat waves that will have widespread impacts on our communities, including heat-related illness and death. These events will also stress infrastructure. Overnight lows will remain excessively high relative to climatological normals, in addition to excessively high daytime temperatures. The next category is the major level, colored red and numbered level 3. These will also be highly impactful events with a major risk of widespread heat-related impacts, again, including illness and mortality. But the duration or intensity may be just a little bit less than a magenta event. Both magenta and red level events represent something in the top 5% of hottest days and nights in the climatological reference period for a location. Moving down the scale, moderate is colored orange and numbered level 2. For most people, this will be uncomfortable heat, with heat-sensitive populations likely experiencing the majority of impacts. It's important to keep in mind that moderate still means some heat-related impacts are to be expected, though, especially during the heat of the day. The minor category, colored yellow and numbered level 1, is the lowest level of elevated heat risk and is likely to impact only the most exposed and heat-intolerant individuals or systems. Finally, green levels of heat risk or base level 0 represent expectations of little to no elevated heat risk with few to no heat-related impacts. Next slide. Heat risk can be evaluated by comparing it to a data set that it wasn't trained on. In this case, emergency department visits. Here we have daily data of heat-related emergency department visits in Maricopa County, Arizona, which were obtained from the Maricopa County Department of Public Health. Maricopa County is where the majority of the Phoenix metro area resides. It is the 15th largest county by area in the US and the 4th largest by population. This is a tremendous data set to look at as it clearly represents acute heat impacts. Someone became ill from heat and sought medical attention. In this graph, we compare the normalized daily emergency department visits to the observed heat risk category using the official weather station in Phoenix. And days where we had heat warnings in effect are also denoted with stars. The impact data reveal a telling story. There is an obvious connection between heat illnesses and the heat risk category. If we average out the emergency department visits by heat risk category, as shown in the bottom right plot, you can see a linear increase between categories. This is just one example of impact-based research that can be done with heat risk. Next slide. Zooming out a bit, here is the emergency department heat-related illness data for the entire contiguous US. These data are combined into the 10 regions, the FEMA HHS regions across the US. For each of the regions, the daily heat illness data were compared to the average observed heat risk values from all available observing stations in each region Those are all those tiny dots. And we looked at the data from April through October from 2019 to 2024. And then each FEMA region has its own chart plotting the data, including the logarithmic correlation. And the center map shows the day with the highest impact rate of any day in that 6-year period, which was during the June 2021 heat wave in the Pacific Northwest. For reference, we in the weather and climate world get excited when we see correlation scores above 0.6. You'll see there is strong correlation between heat risk and the heat illness dataset across all FEMA regions, with the lowest correlation score being 0.81 in FEMA Region 8, and the highest correlation score being 0.90 in FEMA Region 4. This is a great indicator of the utility of heat risk, not just for the big warning days, but also for all of the times when less widespread but still important heat impacts are happening. It also shows that heat risk has done quite well over the 6-year period across the entire CONUS in identifying the bigger events in each region. Next slide. We have seen our partners and users leverage heat risk in a variety of ways, with these examples highlighting just a few applications. We've seen heat risk be used to make decisions on when to open cooling shelters, and in some locations even deciding to make public pools free for all based on the heat risk. We've seen health departments use heat risk to issue health advisories and to provide tailored actions people can take to protect themselves. Emergency managers use heat risk in their emergency operations centers for situational awareness and also include it in their emergency action plans. And schools use heat risk to inform their decisions on outdoor activities. Next slide. I will end with a reminder that while heat risk offers many advantages, it is not the only tool available. Heat index and wet bulb globe temperature are also widely used by our partners and users for decision making. These tools, along with maximum and minimum temperatures, each play a crucial role in communicating heat. Next slide. Okay, so I hope you appreciated learning about heat risk. If you have any questions, you can always reach out to us at the Weather Service Public Program, public.program@NOAA.gov. Thank you.
Thank you, Jess. Even though you said that heat risk is a familiar tool in the West, we see it come up in several different presentations. I think it was very helpful for you to walk through in more detail about how it's created and how to interpret the results and categories. So thank you for walking us through that. We're now going to pass it over to our final presentation from Andrea and Eloise, who is joining us from the city of Grand Junction in Colorado to talk in more detail about urban heat. And I will pass it over to you, Andrea.
Thank you so much. Hello all, my name is Andrea. I'm the Sustainability Specialist with the City of Grand Junction, and joining me is Eloise Armoire, who is our Resilience Fellow. And I'm excited to hear and be informed of all these national tools that are available, and I'm excited to invite you to the local conversation that we are having. So to discuss, we'll give you some framework in case you haven't heard of Grand Junction or know where we're at, of where we are and what our local climate looks like. We'll briefly describe our experience and the data collected with our urban heat island mapping campaign. We'll discuss current projects, and then we'll look forward about the larger context of drought and heat in our area. So where is Grand Junction? We are western Colorado, about 30 miles east of the state line from Utah. So about as west as you can get. And our population is just under 70,000, and we reside in Mesa County, which has 160,000, and that is a pretty comparable mid-sized city, except we are also the largest city between Denver and Salt Lake. So our city does act as a regional hub for the western slope of Colorado. And then we are located at the confluence of the Colorado and Gunnison River. And additionally, our climate is semi-arid and high desert, we do have wide temperature swings, and that's part of all the other climates that are around us. So this picture in the background is taken from the Colorado National Monument, which is about 10 minutes west of downtown Grand Junction. It's also about 2,000 feet higher than Grand Junction. And then across the way, you can see the Book Cliffs, which in this picture have snow when the city does not. That's very likely in the winter. That precipitation and temperature can change dramatically with the elevation. And then just out of frame and about an hour drive away is the Grand Mesa, which is an additional 5,000 feet above Grand Junction at its lower spots. So we have pretty varied climate in our area. And then in addition to drought and heat, I do want to disclose we are surrounded by a wildland-urban interface. So wildfires are definitely another climate hazard aggravated by heat and drought that we are clocking locally. And now I'll pass to Eloise.
Hi, everyone. So this national map shows how extremely hot summer days, defined as days over 95 degrees Fahrenheit, have increased since 1970. We've circled Grand Junction to highlight that while heat is often framed as an urban issue, rural communities like ours are also seeing rising exposure and with fewer resources to adapt to it. And in high desert climates like ours, this trend has implications for health, infrastructure, and labor. Next slide, please. So zooming into Grand Junction, since 1970, we've added about 12 more days per year over 95 degrees Fahrenheit, which is nearly 2 additional weeks of dangerous heat each summer. These hotter, drier conditions not only signal climate change, but also intensify drought, reduce our soil moisture, and create compounding stress on our infrastructure and communities. And heat-related risks is showing up in multiple ways: higher energy demand, limited cooling access, and growing concern for those working outdoors or living without AC. On the right, you can see how this is currently affecting our public health. As Morgan said earlier, these numbers are probably lower than the reality of heat illness, but we can see that statewide in Colorado, heat-related emergency department visits are trending upwards, and Mesa County specifically, where Grand Junction is located, is seeing more frequent and pronounced spikes. So while extreme heat is often viewed, again, as an urban issue, for us, it's a real and rural challenge that we're experiencing. So next, we'll share how we're working to better understand and respond to heat risk.
Yeah. So a big part of understanding urban heat risk is getting better data. We were fortunate to participate in the Urban Heat Island Mapping Campaign with Kappa Strategies. We participated last year, last July, and we had 48 volunteers who became community scientists. You can see the sensors on the car that captured the ambient temperature and the surface temperature that helped produce our temperature models. They drove 8 routes throughout the city and collected over 50,000 measurements. And their work resulted in temperature models that look like this. So this is some of our data. This is the afternoon temperature model. What's important when you're looking at this is the cool spots that are blue are not cool. They're 95 degrees still, so they're still hot. They're just cooler relative to the rest of the city. And what we found is where we have dense development with high traffic areas and buildings and parking lots, those are our hottest parts of Grand Junction. And where we had our blue spots are our pocket parks with our dense mature tree canopy. That really shows the benefits of cooling in our city limits. And to explain that even further, I have a comparison slide here to show our percentage of tree canopy coverage. For our climate, the goal of our tree canopy would be about 15%. Where we have our densest development is also our lowest percentage of tree canopy cover. So how are we using this data? How are we leveraging it further?
Well, we're turning the data that showed us some of our vulnerabilities into action in a couple different ways. First, through urban forestry. We were awarded and then later, unfortunately, had a grant canceled through the Colorado IRA Urban and Community Forestry Program. But we are continuing to pursue up to $50,000 in fiscal year 2026 for irrigation infrastructure, which would support future shade equity and tree planting efforts in the city. Second, in community engagement, the maps are a really strong tool for us to be able to ground conversations with residents, especially when discussing disparities in shade and temperature across different neighborhoods. Third, we're collaborating with external partners. For example, we're contributing to the Mesa County Hazard Mitigation Plan, where for the first time the plan recognizes extreme heat as a serious threat to public health and safety, thanks to the data that we collected. We're also working with CSU Extension. We've actually previously connected with Russ Schumacher, and we're connecting with the agricultural community locally, where extreme heat intersects with drought, health, and labor concerns. Fourth, the data is central to our climate resilience and vulnerability assessment, where it's helping us identify both vulnerable populations and at-risk infrastructure in our city. And finally, we're using it to inform emergency planning, including the city's first ever heat-focused tabletop exercise. And we're using the very NOAA guide that Morgan mentioned to develop this exercise in November, and we'll be evaluating the city's response and coordination during a multi-day extreme heat event scenario.
Further, I think it's fitting. I think Russ's slide was looking at the drought impacts. We highlighted the Colorado River Basin, but we are very aware of how local actions are also regional actions. Our blue star is where where Grand Junction is, and we are right on the Colorado River here coming through. Our watershed that we get, the Connor Creek watershed, is in severe drought right now. Based on our most recent regional water efficiency plan, we calculated out that the average day demand, because we do have rising population in our area, will hit the supply of our watershed by 2039. Fortunately, we've had some really great strides made since that plan was published, that has increased water conservation both in our own infrastructure and through community education. However, climate impacts move that goalpost closer, while local efforts try to push it further away. And currently, we, with our water rights through our watershed, we do lease to the agricultural community. We have a lot of co-benefits through that. When we have to prioritize municipal water use through limited supply, there's a lot of other implications that are, I guess, pun intended, downstream effects that we are considering locally. Additionally, all this data is really important, but I'd really ground it for other local governments who are listening to this call is where this work is really happening is at community events, tabling, and talking about people's experiences with heat, and growing that vernacular of like, what is heat, how is it affecting you, and what resources do you feel like are available? Because heat affects people across our community in wildly different ways. But we are looking forward to collaborating with our community as we go forward in this work. So we'll be on for questions as well. Thank you so much for listening to our local work.
I'm sorry, I was on mute while I was talking. I just want to thank, before we get to questions, Andrea and Eloise. I was really struck by your comment on local actions or regional actions. I think what you shared with us was extraordinary, and you're a model for other communities on using data and taking action with that data and being proactive with current and future hazards. So thank you for taking the time to share the community perspective, which really is ground zero for impacts. We have time for a few questions right now. Elise, if you could put on the main slide deck, that would be great. If you have any questions, Feel free to continue submitting them. Even though we're going to wrap up here in 5 minutes, we can answer your questions offline. And I'll go ahead and I'll start. My first question is going to be for Russ. Russ, this is related to the La Niña. What is the probability that we experience another La Niña this winter?
Yeah, from the CPC's discussion and the graphics there, it looks like about 40 to 50% chance that it'll be La Nina, and similar probability that it'll be neutral conditions for the upcoming winter, with a very low probability of El Nino. So it appears that the two options we have is that it'll either stay neutral or we'll go back into La Nina, and those have about equal odds to each other at this point.
Great, thank you so much. My next question is going to be for Morgan. I have two questions for you, Morgan. The first one, you showed some graphs and data related to heat related to illness for humans. Do you know if there's any data being collected in heat-related deaths of wildlife species, as this might be a better indicator of heat issues because species don't have the capacity to escape the heat. They don't have air conditioning as we do. Any response?
Yeah, that's a great question. I am not aware off the top of my head of any data sets that are that, but more than likely that's something that's probably USDA and Forest Service's preview. So I would check out those two federal agencies and see if they have any data on that.
Great. And a second question for you is, you included a image talking about climate projections of future heat. Would you be able to identify the source of that and put that link in the chat?
Yeah, right when you go to the homepage of Heat.gov, if you scroll down a little bit, we have an interactive map because we have built the website on an ArcGIS platform, so we're able to easily get all that data in. And I believe it's the fifth or sixth tab has the climate projections. And so when you go to that particular tab, it has all the information about the data sources and where this is all coming from.
Oh, that's great. Thank you so much. We still have a few more questions, but we'll try to respond to those offline. We did want to just wrap this webinar up with just a couple more things. If you could go to the next slide, please, Elise. Before we conclude, we did want to highlight the importance of helping your state and other experts know what is happening in your backyard, what's happening on the ground, as this can impact greatly drought monitoring, response, and planning. And one option to do that, if you're not familiar, is to report the conditions through something called the Condition Monitoring Observer Report System. To learn more, and I'll put the link in the chat, please visit this website. Next slide. And one last thank you right now to our speakers, Russ, Morgan, Jessica, Andrea, and Eloise. We had quite a few. You did excellent. Thank you for taking the time to create and deliver such informative presentations for the region. A few quick announcements. Again, a recording will be emailed and posted on Drought.gov shortly. If you're interested in drought resources and information for your specific state, please visit Drought.gov state page, which will have links to relevant resources for your state, such as the Colorado Climate Center. Our next monthly regional drought webinar will be hosted by, it'll be hosted by the Southwest Drought Learning Network in September. And then the Intermountain West Drought webinar will be in October. Look for registration information forthcoming. And finally, when you leave us today, a very short post-webinar survey will pop up. Please take a moment to fill it out. Tell us what you would like to hear about. It will help NIHHIS and our partners improve our delivery of drought information to the region through this webinar series. This webinar is concluded. Thank you again for joining us today, and we hope to see you again in future NIHHIS webinars.